Good afternoon. My name is Leon Jones, and what I'm here to do is I am presenting a presentation based off of the research that I did for ENGT 435W. This is for senior design for the fall of 2024 from Old Dominion University. Instructor is Nestor Escobalis, PE. And basically, what I'm going to talk about during this project is a feasibility study and cost optimization for a new rail line from Bay Head, New Jersey to Atlantic City, New Jersey. Now, the overview for this project is this. I'm going to give you the background, the problem, the methodology, what types of results, future research, and of course, the references. Now, the project all begins with the New Jersey Transit Passenger Rail System. Now, here's the issue here. You have existing infrastructure coming from Philadelphia to Atlantic City, and then from Newark, New Jersey to Atlantic City. Now, the main issue is on the east coast of New Jersey, talking about Palisades Park, Bay Head City, New Jersey, down to Atlantic City, you have the Garden State Parkway, which is primarily filled with traffic. So what I have researched is how we can best move people from Bay Head City, New Jersey to Atlantic City. And I've come up with alternatives. Now, of course, we're not supposed to use calculations, but for the most part, the existing transit line, it crosses again New Jersey from Philadelphia to Atlantic City with no direct transfer to other New Jersey transit sites. And approximately 33 million people throughout the tri-state area, they visit Atlantic City by automobile per year. These visitors play an important role in the city and state economy. However, the volume of high drivers, it contributes to the congestion and poor level of service on New Jersey highways. Again, many visitors do take other modes of transportation, including existing rail to New Jersey. Now, is there an optimal rail layout that could be good to get the high number of visitors to Atlantic City off the roads on a minimum budget? Well, I'm going to discuss a couple of alternatives. And the goal is to choose a more feasible alternative based on demand and optimize a number of stops. And one thing you have to understand about any type of mass transit system is you have to look at what goes into wait time, and queuing, and stops. And what I'm going to show you is a map. It's called an isochrone map. Now, isochrone map is a map between a couple of cities here. This is an isochrone map. And each isochrone has a proposed station. And this isochrone map also lists the number of cities that are right here on this proposed rail line. Now, also, I'm going to talk about the methodology, because what goes into determining all of these numbers. So basically, the methodology is going to include, well, you need a feasibility study, you need permits, you need to acquire land, you need to understand the environment, you need to look at the population. You also need to take the current landscape of existing infrastructure. Is it going to call for a new rail line? Now, for the methodology, what I did, I set up three alternatives. Alternative 0 is a no-build alternative. And during that alternative, you're just going to use the existing infrastructure and facilities. Then I have alternative 1, that's minor improvements for railway from Trenton to Atlantic City. Now this is 73 miles. And then alternative 2, I'm going to build a new rail system from Bayhead to Ebsiscon for a total of 58 miles. Now, I got all these numbers from the New Jersey Department of Transportation and other government facilities. Now, when we go with the no-build alternative, this is the cost right here of the actual infrastructure now. You have your renovations, you have your host HMS building, which hosts your restaurants. You have a 6-story parking garage, your construction of the Atlantic City Expressway, and your Brigantine connector. Now, you have your operations cost for buildings, your maintenance of a building, and your maintenance cost for roadway. Comes out to $428 million. Moving on to the second alternative. And this is basically major improvements for the railway from Trenton to Atlantic City. And that's a 73-mile length. So you have all of your information, your rolling stock, your leases, your passenger facilities, your casino revenue transfer income, your rail infrastructure, your rail support facilities and equipment. Totals $451 million. Now, my research, alternative 2, heavy track, rail passenger facilities, you have right-of-way, park and ride, passenger vehicles, and you have your engineering services, your bridges, your track material, your maintenance of railroad, comes out to a total cost of $354 million. Now, when you deal with any type of transportation facility, you have to have alternatives. Furthermore, there's a lot of politics that goes into transportation projects, particularly if they're massive projects, because where's the money going to come from? It's going to come from the municipalities. Is it going to come from the government? Is it going to come from the state? Now, when I ranked all the alternatives, I took the cost and I came up with the most economic cost. And the most economic alternative was you build a new railway, 58 miles. Now, again, I chose alternative 2 because it costs less to build a new facility. Because when you upgrade a facility, it's already there, but you still have to buy more materials. You still are going to incur maintenance costs, and definitely costs less to build a brand new facility. And also a new system, it's going to reduce traffic on highways and wait times at existing rail systems because, number one, it's going to be shorter in length. And if you're coming from Philadelphia, or if you're coming from Trenton, New Jersey, in that area, you don't have to get on the Garden State Parkway. And also gives one location an advantage over other locations, attracting residential and commercial development that would also occur elsewhere in the region. And that's called economic transfer. More jobs will be created from this brand new rail line. This is all under the methodology. Now, we get into the optimization. This isn't a calculation, but this would be all the variables that would go into minimizing the total cost. Your travel per day, your walking speed, your unit access per day, your length of entire segment, your average speed, your constraints, minimum distance between stations, what would that be? 4 miles. Maximum distance between point A to point B, 58 miles, a minimum number of feasible stations. You basically have 2, and maximum you have 10. Now, I love using maps because the map gives you the route. This is Bayhead, and this is Ebsescon, which is close to Atlantic City, and this is where the new rail line would start and finish. Much shorter. That means people who are coming down from Trenton, Trenton's not on this map, they could actually take a bus line or rail line here, and they don't have to get, this is the Garden State Parkway, US 9. Very congested. This is US 40 and the Atlantic City Expressway. Very congested. And here's Atlantic City right down here. And your Brigantine connector would actually, there's a small rail line here called the Brigantine connector. It'll get you from Ebsescon to Brigantine as well. And here are all the cities: Bayhead, Brick, Toms River, Lacey, Bergen, Barnegat, Stratford, Eagleswood, Port Republic, Galloway, Ebsescon. And again, the utilized National Household Transit Database, it'll estimate the number of a population that uses commuter rail based on a national census. And of course, 2% of the populations utilize commuter rail in persons per daily trip compared to other modes of transportation. And you also have to consider population in surrounding towns within driving access distance using GIS isochrones. Now, again, I'm going to show you what an isochrone is. These are all isochrones right here. All the isochrones are labeled. The first one is your Bayhead Township isochrone, Brick Township, Toms River Township. And along these isochrones, this is where your new stations would be constructed. Now, again, these new stations would be stations where the wait time would be 5 minutes and less. Here's your total population that has to be considered. Number of people and cities. Now, also had to make a few assumptions. The demand density will be based on population data from census as well as historical data. Passengers will use rail line as a round trip. Number of passenger seats and operating speed is going to be based on the characteristics of a single level rail car, which is frequently used for NJ Transit, which is New Jersey Transit. A user is willing to drive an average of 10 minutes to a train station in order to park and take the rail. An average driving access speed is 25 miles per hour. Therefore, a circular isochrone of radius 4.17 miles is used, and the values for per weight access and in travel cost vary in value based on the planner's understanding of the user's preference. Now, basically, here are results. This is what the total cost would be per day. So I actually came up with some numbers here. You have your miles, and this is based off all of the variables that I set up earlier. Your capacity would be 84,782 seats per day. And your demand would be 46,000. And here's the equation where all the information was downloaded to come up with the number. Again, I want to go back to give you an idea of all the variables. You have your users cost, operator cost, location cost, your cost coefficients between 0 and 1, and this is your Q, your total demand. And of course, here's the formula. You have your walking speed, your unit access, your unit in travel cost per day, your unit weight cost, your length of entire segment, your average stopping time, your average speed, your fixed operating cost, and of course, you have your location. And also, looking at the map here, here's what your final layout would look like. Going all the way from Bay Head to Toms River to Lacey to Barnegat to Stafford to Port Republic to Galloway to Obsescon. And this is your isochrone. This is where one station would be for Bay Head, because I blew this map up a little bit so you can see what the isochrones really are. This is your Brick Township, and this is your Toms River. Now, when it comes to this research, because this is based off of theory, there is going to be future research. And I'm saying this because it takes a while for mass transit projects to be constructed. It really takes a long time to get them into the design phase, and then you get them into the constructability phase. Now, we're looking at some could be between 5, 10, 15, 20 years, and it also depends on the administration. Do they want the project, or do they want an alternative, or do they not want the project? Now, population growth, level of service on existing highways, ridership, is there going to be a break even? Is there going to be a cost benefit analysis? Going to have to come up with one to make sure that there's going to be some benefit at a minimum cost. Then again, I mentioned there's going to be politics, financing, environmental impacts, right-of-way issues. Then we actually have to collect real survey data in order to provide a more accurate estimated ridership by utilizing utility functions such as a logic model. And the model can include estimated fare to determine if the line is going to be economically beneficial to New Jersey Transit in the state of New Jersey. And then we have to optimize a timetable. Now, what I did, here are all my references. And if you have any questions, I'm going to go ahead and leave this information up on my YouTube channel as well. And I will be happy to answer every question. You can find me on YouTube on my QCIS channel, LinkedIn, and X, formerly Twitter. But to round everything out, the big problem is you have existing infrastructure along with a lot of people coming from Philadelphia and Trenton, which is a lot of pollution, a lot of money. But for the eastern part of New Jersey, you don't have any mass transit except for the Garden State Parkway, which that's US 9. And the goal is basically to build another railway system so it could be part of the existing infrastructure to move people from Bay Head to Atlantic City. Again, it's going to take someone who's got knowledge of the environment. It's going to take getting the community involved. It's going to take getting your local politicians involved. Where's the money coming from? Because in the end, I do believe that you have the right mass transit system, people are going to use it. People are more environmentally friendly today. And you also have to look at the environment. How will it impact the environment, the economy? It's going to be more development. But overall, this was a research project that talked about mass transit. And I work in the transportation industry, and adequate transportation moves people around. It creates more jobs, more development, and also give people more choices to ride the bus, ride the train, or your own vehicle. Thank you for watching this presentation.